You get your car tuned up. You get your bicycle tuned up. You even got to tune your musical instruments. But when fall and winter give way to spring and summer, and vice versa, did you know you should be having your home's HVAC system tuned up too? If you want to keep your home's climate control system controlling your home's climate, you really should be having your heating, ventilation, and air conditioning components regularly maintained by a licensed professional.
Benefits of routine HVAC tune-ups include improved energy efficiency, preventing pricey repairs, greater reliability, better air quality, extended system lifespan, warranty compliance, preventing hazards like carbon monoxide leaks.
As a dedicated DIYer, I normally advocate for homeowners tending to their own household maintenance obligations. My motto is, if I can do it, you can do it. But if I can't do it, and you can't do it, somebody's got to do it. That's why I'm calling in reinforcements.
This is my HomeServe homie, Randy. He's a bona fide HomeServe HVAC tech, and he's here to show us what an HVAC tune-up comprises and what you should expect in terms of time and cost.
Now, Randy, what level of difficulty would you consider an HVAC tune-up, and is this the sort of thing that the average homeowner could take on for themselves?
I'd say a seasoned technician with a few years of experience, proper training, it's like a 3 or a 4. It's pretty routine. We do so many of them in a season. With a homeowner, though, they don't have the experience, they don't have the tools, or the knowledge of working around electricity. I'd put that way up at a 10, 12, 14. It's high up on that list. There's a lot of things that can go wrong if you don't know what you're doing.
So this is not something that you would recommend that they do for themselves?
Absolutely not. Not what we're going to do.
So how often should a homeowner have an HVAC tune-up performed, and does it make a difference how old their system is?
Air conditioning systems really should be done annually, every year. Age of the unit does play a role. Some of the components might be brittle. So when we're performing a tune-up, we could break a line easily. We could crack the condensate pan. It's old plastic.
First, Randy shuts off the power to the outside condenser. Then we headed inside to check the thermostat.
We want to make sure that it's set in the cooling position so we can get all of our readings while the blower is running. And for conventional thermostats, we want to make sure that it's set in the cooling mode and turned all the way down. We want to see if it needs batteries and then replace them as needed.
Next, he heads, in our case, to the downstairs indoor unit to inspect the electrical components and check for frayed wiring.
We're going to manually move the wheel, and this wheel moves nice and freely.
As well as to test the blower wheel and check the capacitor and blower performance.
We want to see at least plus or minus 3%, 6%, or 10% depending on the capacitor. As we can see, we got 9.6. This is a good capacitor. And then the next step, we're going to check the amps on the blower motor. So we're operating at about 9.14 amps. This is a very large blower motor. That is definitely in the wheelhouse of where it should be. We could compare it to the label that's on the motor itself, or we could refer to the manufacturer specs.
Randy sets the humidifier to off for summer mode and checks the evaporator coil.
What we have here is an uncased coil that the ductwork was wrapped around. There really is no way for us to get in here without cutting a hole in the ductwork. So what we can do is we can pull the humidifier off, remove the water panel. So what we're going to do is we'll just do everything we need to do in here. So we can tell that this is an expansion valve because of this tiny little capillary tube here.
Next, he cleans out the condensate drain line and then replaces the air filter.
The arrow always faces the equipment. Always, always, always. As you can see, we do have quite a bit of buildup on this one versus a clean one. You can do a side-by-side comparison.
He then moves on to taking airflow readings, aka the static pressure test, which tells him the balloon pressure of the ductwork to ensure that correct CFM, cubic feet per minute, is dialed in properly. Now he heads back outside to strip and clean the condenser unit. He checks the electrical panel for any signs of damage.
Sometimes mice will move in, they'll chew wires. So inside here is all the electrical components for this particular style. This is typically 220 volts, single phase. It's a lot of voltage in there. There is absolutely no reason for a homeowner to stick their hands in here, especially if you don't know if the power is off. So we know that there's no power in here. So there's no evidence of any mice damage in here, so we are pretty good with the wires. We can still check them, make sure nothing's broken, no terminals are coming off. Everything here looks pretty good.
Then he disconnects the electrical components and removes the panels and top for a deep cleaning from the inside out. Ooh, look at that buildup.
So what is happening is this is blowing air out and it's sucking air in through the coil. So as you're sucking air in, it gets matted up with pollen, dirt, dust, grass, all sorts of debris that can build up on it.
Randy says that in areas with heavy cottonseed, such as where we are today, it may be necessary to have an HVAC tune-up performed twice a year.
So the other step that we need to check while we're out here is to make sure that the fan motor moves nice and freely. If it were bound up or stiff, we would be recommending a new fan motor. In this case, this one moves nice and easy.
Now that the unit is clean, Randy performs a voltage drop to ensure that the contactor isn't dirty.
So 0.024, that's as close to zero as I think we're gonna get. This contactor is perfectly fine. Now that I've got the system back up and running, I need to let it equalize. I just hit it with 45, 50 degree water. So we have to let this come up to speed, run, let it stabilize.
Once equalized, he'll check the system for the subcool.
And everything is good. The manufacturer is looking for an 8-degree subcool on a day like today, and we're operating right at 8. So we should have a really good delta T when we go inside.
Then he heads inside to check the delta T, which, of course I know what that is. But Randy, why don't you give us a refresher for the viewer's sake?
The delta T is the temperature of the return minus the temperature of the supply air. We typically look for a 16 to about 21, 22 degree range. We're operating at 48 degrees on the supply, 69 degrees on the return, giving us a 20 degree delta T. System's working perfect.
That was exhausting.
It's a lot of work. A lot of work.
You're telling me. Now, Randy, let's get down to brass tacks now that we've done this. What's this going to cost me?
It's a tricky question. It will vary depending on where you're located in the country, regionally, any promotion that's happening, the company that you call, and the time that you're watching this video. So you can look in the description of this video to see what the national average is currently.
Besides scheduling their annual or biannual HVAC tune-ups, what's the most important thing homeowners can do to keep their HVAC system humming?
I'd say number one is to keep up with the replacement of the filter. Most filters are 90 days or even less. So you're talking at least every 3 months replacing that filter. Number two is they can wash the condenser outside. They gotta shut the power off, whether it's at the breaker or the disconnect outside, they gotta shut it off. You can't just go in there blasting it with water while it's running. So those are really the two important things. Washing it and replacing the filter, gotta do it.
So having seen this, homeowners, what do you think? DIY dilemma or a problem for the pros? Let us know in the comments.
Oh, thank God.